So again I am repeating once more for you. So this force on this charge q1 is net force F1. How this F12 how will we calculate F12? The both the charges q and q and the distance between them L and the angle between them is this 120 degree. So this F12 simply comes 1 upon 4 pi epsilon naught, and this q1 q2 both are q and distance between them L square. Let us consider it as F. So this F12 is F. Similarly, if we see this is also F, because charges are same, only there is a minus sign, that means this is attractive force. And then we use the law of parallelogram to calculate the force, resultant force F1, and the angle between them was 120 degree, and cos 120 degree is 1 by 2 minus 1 by 2. So net resultant F1 was F. Similarly, this is F, this is F, and angle between them is again 120 degree. So net this resultant is again F. You can calculate using the law of parallelogram. For this third one, this is the direction of first force, this is the direction of second force. Again these two are F, but the angle between them is not 120 degree but 60 degree. So this time it has to be plus. So F square plus another F square plus 2F1 F2, that means FF 2F square cos 60 degree. So third is also plus. So this comes out as under root 3F square. When you take it out, so this F comes out and root 3 remains. So this is the whole story of these three forces. So now we have calculated the forces on all of them. So let us understand this thing, what they have written. Solution: the forces acting on charge q at A, this one, due to charges B and charges C. At C it is minus q, are F12, this is F12 because of this, and F13 because of this, okay, respectively, as shown in figure 1.10. By parallelogram law we have calculated this F1 on the charge. So here we can see that F1 was F, simply magnitude was F, only thing remaining was the direction, which was, let us say, this R1, unit vector R1, okay. So magnitude was 1 upon 4 pi epsilon naught. The charges were q1 and minus, both the charges were q and q, whether it is positive or negative, and the distance between them is again L. So this remains same. So this F1 is in this direction, the unit vector R is a vector which has unit in this direction, okay. Similarly, F2 we had calculated F2 is again F, magnitude was same F, only thing was the direction was changed. The direction is in this side, R2, okay, unit vector R2, where R2 is unit vector along AC. So now let us understand this important thing. See, this whole angle is 180 degree, this is 60 degree, this is 60, and this is 120. This one is 120, this one is 60, this one is 120, and this whole is 180 degree, you know. So now half of this 120 is 60 degree. So this angle, this angle is 60 degree from this. Similarly, this whole angle is 180 degree, this angle is 120, this angle is 60 degree. So again this F2 makes 60 degree from this side, 60 degree from this side. So what we have seen is this F2 is making 60 degree from this triangle this side and 60 degree from this side. Similarly, F1 making 60 degree from this side and 60 degree from this side. So how can we use this use this to calculate the net resultant force. So if we go further, here it is written that similarly total force on charge minus q, since on this minus q both the forces are attractive, this side, and angle between them is 60 degree, and cos 60 degree is plus 1 by 2. So this comes out root 3f, and they have considered this as a unit vector n. This is unit vector n, this is unit vector r2, and this one was unit vector r1. So all three unit vectors are there. So this is they have considered, and when we say that it is interesting to see the sum of the forces on three charges is 0. So this is something that you have to prove, how this F1, F2 and F3 are equal to 0. The result is not surprising. Definitely the result is not surprising, because Coulomb's law is consistent with Newton's third law. That means all the charges, the vector sum of all, since these are vector, their sum must be 0, otherwise it will violate Newton's third law, and we cannot violate Newton's third law. But how this F1, F2 plus F3 is 0? Let us see. So first force F1 was, what was F1? F1 was F, okay, and this unit vector R1. Then F2, what was F2? F2 was again F unit vector R2. What was this F3? F3 was F under root 3 F and unit vector n. So these were the three things. So let us bring these two charges, these two forces closer. So one force F2 is in this direction, okay, and this F1 is in this direction. This is F1 and this is F2. So if you measure the angle between them, so this angle is again 60 degree. This angle is 60 degree. So 60 degree, this angle is 60 degree. How? This is parallel to this, and this is parallel to this, and few minutes back we had calculated that this angle is 60 degree. So the angle between F1 and F2 is 60 degree. Since this angle is 60 degree and the resultant is in this direction, so from the vector law, parallelogram law of vectors, we will get net resultant force F is equal to, F1 is F, again F square, again F2 is F square, plus 2F1 F2, that means 2F square cos 60 degree. But what we can see, this will also come out, this resultant force will also come out under root 3F. Let us say this F dash. So this is F dash is equal to root 3F. But what you can see, one has direction on this side, another one has direction on this side. So here we can see that this F3 is equal to minus of this F dash. So both will cancel out, hence the Newton's law will be validated in this case. So here we have seen that F1 is equal to F, F2 is equal to F as well. This F3 is under root 3F. When we calculated the resultant of F1 and F2, the angle between them was 60 degree and the resultant was equal to F3 in magnitude but opposite in direction, which will cancel out. Hence, it has been proved that the sum of all three, vector sum of all three forces F1, F2 and F3 is 0, which is consistent with Newton's third law.